battery management systems in EV. So it is presented by Dr. Ben, Assistant Professor, Chipley, PSM College of Engineering and Technology. So why battery management system is needed in EV? So battery, so it is one of the most expensive and critical EV component which is present in the electrical vehicle. So nearly 30 to 40% of cost of EV belongs to the battery. Okay. So also it is one of the most critical EV component because the batteries which are used in the EVs especially made up of lithium ion batteries which are highly sensitive to overcharges, over discharges and operating temperatures. So it is one of the critical controlled environment to deal with EV battery management when it operates with different conditions. So the BMS should ensure a good level of safety. It should yield a good long battery life, and it should produce a reliable vehicle operation because so as consumer buy EVs, so we have to give a reliable and a long life to the customer point of view. Okay, so without BMS, EV becomes a failure product and it also lead to hazardous one and it can lead to fire risk. Next, what is a BMS? The basic definition of BMS is, so it is an electronic control unit. It consists of a lot of electronic components to monitor the performance of the battery which is present in the EV, and it protects and it optimizes the battery that is present in the EV. So how it monitors, in the sense, what are the conditions it monitors in the sense? It monitors the level of charging current, it monitors the level of discharging current, it monitors the voltage at which the battery is charged or discharged, and it protects the battery from the thermal conditions, especially so unsafe thermal conditions is being experienced in battery management system batteries in EVs. So the thermal conditions can be avoided by means of a battery management system, and it optimizes various parameters such as state of health, state of charge, depth of discharge, so that we can increase the battery life. Okay, so overall a battery management system is a control unit, centralized or decentralized control unit that monitors, protects and optimizes the battery performance in an EV. So in simple words we can say it acts as a brain as well as the guardian of the battery pack. So next, where BMS sits in an EV. So the battery cells consists, a group of battery cells is known as a battery pack, and this battery pack, okay, is fitted physically in the EV and it is electronically connected to the battery, motor controller, charger and vehicle electronic control unit. Okay, also it is connected to lot of aiding equipments, and it is also connected to the infotainment systems. So it has a separate part to be seated in physically. In physical systems, it is seated over the inside the battery pack, and in electronics and electrical connection systems, it is connected to the motor control unit, the charge unit and the vehicle ECUs. Also, this is the outline of the battery management system position. So it consists of the various amount of lithium ion cells which is connected in series and it is connected in parallel, and this clusters of lithium ion cells is connected with the battery management system, and this battery management system individual units are connected by means of a collective unit, and where it is connected to the CAN buses. So CAN buses is a controller area network buses. Okay, it can communicate with the electrical vehicles, so control units, okay, and it is a two-wire communication, and also it is connected without a central controller, because its data exchange is between each and every control unit. Okay, so BMS is connected to different systems. Either it is a charge controller, either it is an infotainment system, either it is a temperature controller. It is communicated with different by means of address, not by means of power lines. Okay. Also, the system of communication is a broadcast system of communication is followed in these types of BMS. So the main functions of BMS. So the BMS, the battery management system, follows some of the main functions, out of which 7 are listed here. First is cell voltage monitoring, second is current monitoring, next is temperature monitoring, fourth is state estimation, especially state of charge and state of health, cell balancing, protection and fault handling, communication with vehicles. And here in cell voltage monitoring, the voltage of each and every cell is monitored, so to maintain a healthy state of charging. And in current monitoring, the measure of charging current and discharging current and the overall battery current is monitored. And in temperature monitoring, so to avoid overheating and thermal runaway conditions, so we are in a purpose to monitor the temperature of the battery of each and every cell. What is the condition, what is the thermal condition, what is the state of each and every cell by means of thermal loads. So everything we have to monitor, and that is monitored by the battery management system. And so next, another form of performance of the battery that the customer view is the aging and the life of the battery. So if I am buying an EV, so how much it will long, how much the battery longs, how much, what is the time span of the battery to be healthy. So all the things the customer will raise a question, and the developer or the commercializer should have to address these types of questions. So estimation is done by means of different sensors, and it is one of the important key function of a battery management system. And next is cell balancing. So each and every cell, even if it is made by the same manufacturer, has different level of physical, chemical and thermal conditions. Each and every cell is different from everyone. So one will have a high level of voltage charging, and another will have a low level of voltage charging. So in order to balance and remove the uncertainty present between the cells, we should have the main aid of battery management system, which it performs by balancing each and every cell for different conditions. And next is the protection and fault handling. The battery management systems has different protection parts, protection circuits and fault handling circuits, where the fault in each and every cell is monitored, and if any discrepancies arise, definitely it will intimate within a fraction of a second, and depending upon the fault, range of fault, the BMS isolates the battery and the vehicle. And next, communication with the vehicle. So each and every path of the vehicle is being monitored. Each and every state of vehicle is monitored by this BMS, and everything is intimated to the customer through communication. So it is not in my point of view, BMS is not a single function, but it is a complete battery supervision, and which is the father of all controls of the EV. So next, coming to the BMS block diagram. So BMS, this slide shows the internal block diagram of BMS. It explains how hardware and software blocks work together to monitor and protect the EV battery. So it consists of a sensing block. Okay, sensing block in the sense to monitor the voltage, of each and every cell, to monitor voltage of each and every clusters, either series pathways or parallel pathways, a voltage sensor is introduced there. So it measures the voltage and it delivers the range of voltage to the battery management system. Accordingly, the battery management system decides whether to charge, whether to discharge, or to adhere with the needs of the vehicle control unit. And next sensor unit is the current sensor unit, where the charging and discharging current are being monitored. Next is temperature sensor. So in order to evaluate and estimate the range of the temperature withstanding capacity of the EV and the range at which it is working, so we need a temperature sensor, and that sensor gives the estimate value. The input and output are both controlled by the BMS unit in order to have a good optimal thermal condition. Next is the battery monitoring IC. So this battery monitoring IC runs the algorithm. It is not a directly like a sensor unit. It is not directly equipment like a sensor unit, but it measures the state of the battery and it runs the algorithm. It measures different values and runs an algorithm, and it finally estimates the state of charge, the state of health, and it estimates the safety level of the battery and the vehicle. So finally the protection blocks, and this protection block have the relay contactors and protecting circuit and over voltage, current, and temperature. So next is the cell balancing unit. It is present inside the battery pack. It is controlled by the BMS unit, and it estimates whether equal voltage is maintained in all cells. And this is very much important to increase the efficiency, to increase the performance, to increase the life, to get the better battery life, and to reduce the aging conditions. So, and finally it is connected to the CAN bus controller. As already we discussed, it is one of the addressing bus, and this addressing bus communicates between the electronic units, infotainment systems, motor charge controllers, and it is being controlled by the battery management systems, and it can decide what is the condition at which the data is being transferred, and everything related to communication is handled by this CAN bus. And next, battery cell, and this is one of the another block diagram of battery management system. So here, so this is the low voltage, the slim red lines are the low voltage line, and the bold lines are the battery voltage line. So here different types of protection is being given. Initially the overcurrent protection to avoid the high discharging and high discharging and low charging, and current sensor where the current is sensed and the current ratio is being adjusted between the vehicle discharging battery discharging unit and the vehicle requirement, and a fuse is given to avoid the overcurrent, and the bidirectional solid state switch, especially the MOSFET power MOSFET is being used. It switch on and switch off depending upon the requirement. And next is the battery cell monitor. So EV is not a single battery. EV batteries is a cluster of batteries, and it has a series and parallel connections of a lot of battery cells. So each lithium ion cell voltage ranges the minimum level of 3 volt and a maximum level of 4.2 volt. So there are hundreds of cells in the EV battery pack, and the BMS continuously check the individual cell voltage. So if one cell is faulty, so it will intimate, and the protection circuits come for protection if there is a thermal damage, and the other control units comes to support the system whether it is high or low voltage is detected between the units, and detects weak and faulty cells. Okay, the battery cell monitoring so detects weak and the faulty cells. So one code that is set by the So battery management system is, so a battery pack is only strong as it's the weakest. So it means that if there is a weak cell of having 3.1 volt or 3.2 volt, so it is the maximum capacity of the entire battery pack. Okay, one battery, if it is having 3.2 volt of charging capacity, the volt of volt maintenance, okay, it gives all over the total cells is responsible to give only 3.2 volt and not more than that. So one weak cell can damage the entire battery pack. Okay, and the current measurement. So current, for measuring the current, so especially charging and discharging current, there may be two types of resistors. So initially the shunt resistor will be there, and secondly Hall effect sensors are there. So one advantage of shunt resistor is it basically works as an elementary unit and it is less expensive, and Hall effect sensor gives a different advantage of a good control and isolation. That is one of the important part of this Hall effect sensor. So and important for it is very much, current measurement is highly important for SOC calculation and over current protection. If the current exceeds, the shunt resistor or the Hall effect sensor intimates, and then the current, over current is being, protection is being given. And for SOC calculation, so the current sensor senses the value of the current, either it is charging or discharging, depending on the condition. The state of charge is delivered as in the mobile batteries. So temperature monitoring. So temperature sensors are being engaged to monitor the temperature of the battery. So here initially NTC sensors are used. Basically NTC's sensors are negative temperature coefficient sensor. So the negative temperature coefficient sensors, as the resistance increases, as the temperature increases, the resistance also decreases. Okay, it is both are connected inversely proportional, unlike the PTCs. So it becomes, as the temperature of the battery increases, the resistance value decreases, and accordingly we can measure the range of the temperature. The normal safe operating range of the lithium ion battery is between 15 degrees centigrade to 45 degrees centigrade. This temperature range is highly safe and it gives a good operating life for the battery. And next is over temperature in BMS. Okay, at low temperature, the BMS limits the charge. So that is one of the important point I have to mention here, is at lower temperature the BMS limit charging. So this charging has, when it is connected to the cold temperatures, so it causes less amount of charging, and it results in internal damage of the cells. Temperature monitoring. So this is the outline of temperature monitoring. There are different types of temperature monitoring. So initially ambient air is used. So ambient air is used and then it is passed to the exhaust systems. So here the battery pack is being cooled using ambient temperature only, and next the ambient temperature is used with the evaporator systems, is passed to the evaporator systems, and the battery pack is being cooled, and next a refrigerant is connected. So this becomes a normal cooling method, so which is present as in the heat exchangers. And next battery pack is connected to the fins. So here both air and liquid cooling are being used, and in the next option direct contact with the jacket, that is the coolant is circulated within the battery pack. And next the battery pack is connected with the chiller unit instead of evaporator, and phase changing, and the next final is phase changing material is coated over in the outer portion of the battery pack, by which the cooling can be attained. So next, protection functions. So there are 5 different protection functions, that is over voltage, under voltage, over current, short circuit current, and over temperature. So safety is one of the top priority of the battery management system. Over voltage protection. So when the battery is being charged, if it exceeds the voltage level that is prescribed for the battery, so the battery management system, especially the protection functions, immediately stops the battery from charging. And also in the next case, if it is an under voltage protection, if you are running a vehicle for a long time, you are going for a long ride, so if the range of the battery comes down, okay, the voltage level also being reduced. This creates range anxiety in customers. However, it should be, the battery should be even protected apart from the range anxiety. So the protection circuits or the protection functional units will stop the vehicle automatically and isolate the battery, and this protection is necessary to improve the state of health of the battery. And over current protection, so this is also while charging, so the BMS measures each and every current value of the battery cell packs. If something is found discrepant, then it will stops and it will intimate the customer, or it will give the management system an intimation about the fault. Okay, this prevents the high discharging or low charging currents and vice versa. And in case of short circuits, if any short circuit is achieved or attained due to any thermal exterior, any environmental conditions or any exterior conditions, so immediately the battery management systems will switch off the relays and the protection units, and the breakers are being triggered instantly to give the short circuit protection. As we discussed earlier, over temperature is hazardous to the battery, and which is also prevented by means of this battery management system. So as I said, safety is the top priority when it comes to BMS, because it occupies nearly 40% of the total cost associated with the electrical vehicle system. Next is the state of charge. So state of charge is the charge that is totally present in the battery. Simply by saying, if the battery is fully charged, we can say the battery is charged at the percentage of 100. And in the next case, if the battery is showing a low battery warning, then the battery state is 20%. These are just the numbers and not exact values. So 100% fully charged means the state of health is good and state of charge is good, and 20% battery charging means the state of charge is very low. So this is done by three methods: Coulomb counting, voltage based estimation, and model based estimation. So this Coulomb counting, so the counting of the current parameter with reference to the time. Okay, this method is one of the efficient method to estimate state of charge. So the battery management system continuously counts the charge and continuously count the state of charge by means of estimating the value of current through any one of these methods. These are very similar to mobile phone batteries. So in Coulomb counting, the current is integrated over time and the value of current is estimated, through which the state of charge value is being accounted. So without proper SOC, we can't be able to predict the range of the vehicle. So this parameter, which is estimated by the battery management systems, it becomes one of the critical parameter and an important parameter to decide the vehicle traveling distance. It is similar to the fuel gauge which is present in the normal conventional IC engine vehicles. And the next is state of health. So the state of health is the condition that tells about how the battery is. It is a battery aging indicator, so in which the battery's health is compared with the brand new battery. Okay, if you are buying a car, so after 1 month you are charging and discharging the vehicle, so the some internal resistance increases. So this internal resistance and other parametrical difference makes the new battery to an old one. So however, the state of health is a comparison of the health of a brand new battery with the 1 month battery. So definitely SOH will not be 100% for a 1 month used battery, and it will be 100% for the new battery. And as the battery gets old, the state of health decreases. So this state of health has three major contributors for its depreciations. One is charging cycles, second is temperature history, and the usage patterns. So charging cycles, how much time we charge and discharge, becomes one of the important criteria that decides the state of health. And temperature history. So if you are continuously riding it for a long distance for large amount of time, the temperature of the battery increases adequately. So this temperature increase definitely reduces the state of health of the battery. And usage patterns, the customer usage patterns, the frequent charging and discharging of the battery without making it as full is one of the important contributor for the state of health conditions. So if a person's habit is poor, definitely the EV battery health is also will be very poor. So determines batteries replacement time. So state of health is one of them important parameter to determine the state of health. So and cell balancing. Why balancing? Cells definitely even with the same manufacturer can't able to charge and discharge evenly. So definitely there will be uneven conditions. So unbalanced cells reduces the capacity of the entire battery. So there are two types of cell balancing. Initially passive balancing and next is active balancing. In passive balancing, excess energy present in one of the cell of the battery pack is wasted as heat, and entirely all the voltage levels of entire cell is maintained evenly. In active balancing, if an cell is overcharged, the energy present in the overcharged battery is transferred to the next cell. Okay, this is active power balancing. And BMS communication system. So it uses controller area network. It communicates with the vehicle control unit, charger, and the consumer dashboard. It enables the status of the battery, and it gives the fault alerts, and it gives the charging control to the charge controller, and discharging control to the charge controller while driving. So it mainly consists of input output unit, so common electronic control unit, and the various device connected to the EV such as regenerative braking systems, so and motor and other accessories. And BMS during charging checks the cell voltage limit, temperature limit, and control the charging current and yield charging cutoff, which prevents overcharging and thermal runaway. So while driving, it supplies the real-time data about the battery range and various other aspects related to the EV conditions. And next, it limits the power if the battery is overstressed, and it ensures smooth and safe operation. BMS works continuously even when the vehicle is driving. and there are various types of battery management system architecture. Initially, centralized battery management system, where the battery management, all the batteries are connected to the control unit, and that control unit is solely controlled by the battery management system. And next is the distributed battery management system, in which each and every battery is connected to the BMS, and it is commonly connected to a control unit. And next is modular BMS, that is, as in other simple words, we can say it as a customized one. So each and every battery is given to the control unit, and that control unit is connected to the main control unit, and that main control unit is connected to the battery management system. So these are the different types of architecture of battery management systems. So also, even though there is advantages, there is challenges in BMS. So some of the challenges are accurate SOC estimation, cell-to-cell variation of voltage and other parameters, thermal management. Thermal runaway is one of the biggest challenge in battery management system, and the cost versus the safety trade-off is one of the biggest challenge in terms of economical aspects of the BMS design. And in future EVs, the cyber security, especially in autonomous vehicles, so the cyber security issues is going to become a biggest BMS challenge. And future trends are AI based SOC estimation, cloud connected battery management system, predictive fault detection, which is highly useful for unexpected conditions during long rides and during traffical conditions, and solid state battery management systems. And BMS will become even smarter and smarter ever while during the upcoming future. Thank you.